so before we get started with our next lesson, I just want to recap what we have been doing so far in pre-algebra this year. If you remember way back to a couple of months ago when we first got together, we started learning about integers and the rules of combining them and multiplying and dividing them. We moved on to the different properties of addition and multiplication, the associative property, the commutative property. Then we went on to the distributive property. After that, we learned about the identity theories, the identity theory of addition, in which we went over adding a 0 to a number does not change its value. We also learned about the identity in multiplication, where multiplying a number by 1 keeps it the same number. Then what we did was we started learning about expressions and variables and the different terms, and then we moved into solving equations. And that's what we've been doing for the past few weeks, solving different kinds of equations using inverse operations and always succeeding at our goal, finding out what the variable is, isolating the variable. So what we've been doing is, now that we are in equations, we have gradually been tackling more and more challenging equations. So we had one-step equations where we just had to use one operation to isolate the variable. Then we moved on to two-step equations where we had the variable being paired with either a coefficient or being divided by a number and a constant. Then what we did was we threw in the distributive property, so we had multi-step equations. And now what you can see is we are up to solving equations that have variables on both sides. And the reason I took these first few minutes to go over what we've done is just to remind you, firstly, of how much you've learned so far in fewer than 2 months of school. Secondly, it's just to show you that we are going to use everything that you've learned already and apply it to these very challenging equations. Just as we always do, we're going to get started with reading over our vocabulary. And because there isn't really any new skill this time, we have a redundancy in our vocabulary, but it pays to refresh our memories. First, we have the word equation. And you know that an equation is a mathematical sentence that has two equivalent expressions with an equal sign in between them. Our second vocabulary term is the solution of an equation. When we are talking about finding the solution, we're talking about finding out what the value of the variable is. And then finally, inverse operations, which you know are operations that undo each other. Addition and subtraction are inverse operations. Multiplication and division are also inverse operations. Now let's get started with the first of our 5 examples. Now, because these problems are more challenging than we're used to, I have done away with word problems for this lesson. We will come back to word problems in the lesson that follows this. So our directions here simply are to solve. I'm going to read the problem. We have 25x plus 74 equals 92 plus 23x. And as you can see, both sides of the equation have a constant and both have a variable term. And what we're going to do is to move our variable terms to one side of the equation and our constants to the other. Now for this one, what we'll do is we'll move our x's to the left and our constants to the right. And our goal doesn't waver. We have not wavered from our goal. Isolate the variable. So what we're going to do first, because I see we have a positive 23x here, we are going to put a negative 23x on both sides so that we can zero this out. We're going to do the opposite of having a positive 23x. I'll move over here. So we have already 25x and a positive 74, and we are going to apply or add on our negative 23x. Next, I'll write this whole expression as it is, 92 plus 23x, and then I'll put on our negative 23x. Over here, we're going to combine our like terms. We have a positive 25x and a negative 23x. Together, those make a positive 2x. And we can't forget our constant, so we'll bring him down. And let's see what we did over here. Our positive 23x and our negative 23x together make a 0. And that leaves us with just a positive 92. So we're halfway to our goal. We have our variable terms here. We're down to 1. Now what we have to do is think back to what we did when we were solving two-step equations. We have to get rid of the constant first, negate the constant, because it's easier to get rid of that than to get the coefficient. So we are going to use inverse operations and pair our positive 74 with a negative 74. And because this is an equation, it has to be balanced and fair. We put our negative 74 over there. Now again, we are zeroing out our constant, and that leaves us with just 2x. Over here, we're going to simplify our 92 and a negative 74. That leaves us with a positive 18. Now that we see we have our variable being multiplied by a positive 2, and the way to undo that is to divide both sides by a positive 2. And when we do, we have a coefficient of 1 for our x, and we find that x equals positive 9. So the solution to this very long, very unfriendly looking equation is that x equals 9. Now let's take a look at example 2. Here we have a problem that is very similar to what we just solved, except what I did was I added a set of parentheses. Now let's take a look at what we have. We have negative 9x plus 15 equals a negative 22 minus 4 times the quantity x plus 12. Sounds like a lot. But really, just remind yourself, you already know all the steps you need. You have the skill set. Because PEMDAS, order of operations, tells us we have to take care of our parentheses first, I'm just going to bring down this part of the equation and keep it there until later. Now let's take a look at what we have here. We have a negative 22, we have a negative 4, and we have a set of parentheses. Here is where most mistakes happen. A lot of times people will see the negative 22 minus 4 and right away want to combine those terms. What we have to see here is that this 4 is connected. It belongs to this set of parentheses. So this negative 22 has nothing to do with this part of the expression yet. Now what we're going to do is use distributive property. Notice I'm circling the negative 4 because I always want to remind myself that the symbol goes with the number. And now we have to distribute this negative 4 times x. And because we've been doing this for several weeks already, I'm going to just right away put down the new term. I'm not going to write down negative 4 times x and then the next term. So negative 4 times x is a negative 4x. And then negative 4 times a positive 12 gives us a negative 48. So now we have to do some combining of like terms and shifting around. Now I see I have 3 terms over here. So again, I'm just going to leave this negative 9x plus 15 alone. And what I see here is I recognize that I have like terms. I have 2 constants here, a negative 22 and a negative 48. So I'm going to right away combine those, and together they make a negative 70. And I'll bring down my variable term, negative 4x. So now our problem is similar to what we did in example 1. And again, we're going to move all our variables to one side and keep our constants in the other. Now I know oftentimes we like to have, or most people like to have, the variables on the left side. But what I want to do purposely right now is to have the variables be on the right, so that on the times when you encounter the variables on the right, it doesn't make you second guess yourself or feel confused. So, for this problem, we're going to take this negative 9x and we want to zero it out. The opposite of a negative 9x is to have a positive 9x. So I'm going to put a positive 9x on both sides. Here we have negative 70, negative 4x, and our positive 9x. What we did here was exactly what we wanted. We zeroed out our x's, and we're left with a positive 15. Now over here, we have one constant, so I'll bring it down. And this, we have two like terms. We have a negative 4x and a positive 9x. Together they make a positive 5x. So we're one step closer. What we're left with now, we boiled this down to a two-step equation where we have the x. X isn't alone yet. Why? Because it has a negative 70 with it, and it's being multiplied by a positive 5. So we're going to get rid of that negative 70 first by putting a positive 70 on both sides. When we combine these two constants, we have 85. Now this negative 70 and that positive 70 cancel each other out. We have 85 equals positive 5x. We have only one more step to go. We see that our x is being multiplied by 5. So to undo that, we are going to divide by 5 on both sides. And what we have left is that x equals 85 divided by 5 is 17. And positive 17 is a solution to example number 2. Okay, now, again, we have distributive property. So we're going to take care of that first. PEMDAS tells us, take care of our parentheses first. Distributive property means we take our positive 4 and we multiply it to every term within the parentheses. So positive 4 times a negative 2x gives us a negative 8x. A positive 4 times a positive 3 equals a positive 12. Now let's take care of this side. There's really nothing to do, so we're just going to bring down this part of the equation. Negative 15 minus 8x. So we're going to do what we did in example 1 and example 2. We're going to move all of our constants to one side and have the variable terms on the other. I see negative 8x on this side, so what I'm going to do is put a positive 8x on both sides because we want the x alone. So we have negative 8x plus 12 plus 8x equals negative 15 minus 8x, and then our positive, positive 8x. Now take a look what happens. Here we have a negative 8x, remember we're going to combine our like terms, and a positive 8x. So what happens? A negative 8 and a positive 8 cancel each other out, and that gives us just positive 12. Let's take a look at what happened over here. We have a negative 8x and a positive 8x. We lost all our x's. We lost all our variable terms. And what are we left with? We have a positive 12 equals negative 15. Positive 12 does not equal a negative 15. So when we encounter this kind of problem, we say that there is no solution. This doesn't happen often, but you will definitely see this again in pre-algebra. Just because an equation is set doesn't mean it can be solved. Okay, let's take a look at this. 6x plus 2 equals 2 times the quantity, 3x plus 1. There are no like terms here, and there are no parentheses, so I'm going to bring that expression right down. And now I'm going to use a distributive property to simplify this side. We have 2 times 3x, which is 6x, and 2 times 1, which is a positive 2. And now look what we have. On both sides of this equation, we have the exact same expression, 6x plus 2. Now when that happens, what that means is this equation has an infinite number of solutions, meaning that no matter what value you assign to x, you will always get the same number on both sides of the equation. Let's try it. Let's just say x will equal 3. So what I'm going to do is rewrite our original expression, our original equation, and this time substitute a 3 for our x. So we have 6x plus 2 equals 2 times the quantity, 3x plus 1. So now instead of 6x, we'll have 6 times 3, which is 18, plus 2, equals 2 times the quantity, 3x, but if we're calling x 3, we have 3 times 3, which is 9, plus 1. 18 plus 2 is 20. 2 times, let's simplify this, 9 plus 1 is 10. 2 times 10 is 20 again. So you see 20 does equal 20. Let's do it one more time. This time, let's say that x will equal, I don't know, how about a negative 5? So again, we're going to go to our original equation. 6x plus 2 equals 2 times the quantity, 3x plus 1. But remember, what we're going to do is substitute our negative 5. So I'm just going to put a little negative 5 up here. 6 times negative 5 gives us negative 30. We'll add a positive 2. 2 times the quantity, we have 3 times the negative 5, which gives us a negative 15 and a positive 1. Negative 30 and a positive 2 together make a negative 28. 2 times the quantity, a negative 15 and a positive 1 make a negative 14. So you see negative 28 equals 2 times a negative 14 is negative 28. So sometimes you'll see problems like we did in number 3 where there are no solutions, And then once in a while, you'll encounter a problem like number 4, where there are an infinite number of solutions. We have one more problem, and then we're done for tonight. What we're going to do now is use the same idea that we've been doing, solving equations that have variables on both sides, but we're going to use it in a geometry question. We have to find the length. And you might think, well, how are we going to do that? We have variables in both names of the length. When you see a problem like this, remember, in a rectangle, and we're assuming this is a rectangle even though I didn't draw it that well, two sides that are parallel are the same length. So when you see a problem like this, you would take the one length, 7x plus 30, and you will make it equal to your second length, because the length of this side is equal to the length of this side. And what we're going to do is take our variable term, since we have only a variable term here on the right, no constant. There's no point in taking this constant and moving it. So we're going to eliminate that step and get rid of this positive 7x so that all our x's are on the right side. And I'm going to do that. Remember inverse operations. What's the opposite of having a positive 7x here? Having a negative 7x. So we have 7x plus 30, and then our negative 7x equals our original 12x, and then a negative 7x. This positive 7x and negative 7x cancel each other out. So we have a positive 30. Now our positive 12x and our negative 7x combined make a positive 5x. Then what we need to do, see right now, we see that the x is being multiplied by 5. So we need to divide by 5, because that will get the x by itself. We have x equals 30 divided by 5 is 6. Now, most times, when we find the value of the variable, we have finished. We have solved our problem. But not in a case like this, because if you look, we want to know what the length of that rectangle is. We haven't found that yet. Well, we did find the missing piece that we need to help us. So let's move over here. And what we're going to do is take our 6, we'll take our solution, and substitute it into each of these expressions just to check ourselves. We want to make sure we get the same answer each time. Let's take this one first, 12x, which would make it 12 times our solution, 6. 12 times 6 equals 72 units. Now let's see if that will work for this expression. 7x plus 30. But instead of 7x, we have 7 times our solution, 6. 7 times 6 is 42. Plus 30. And we have 72. So we've just proven that our solution is correct. So again, just to reiterate what I said at the beginning of this lesson, these problems, these equations are challenging. They look daunting, and they will probably make you a little nervous. But now, hopefully, now that you have worked at these problems and copied and listened and followed along, you will have at least a little bit of an understanding of how to solve these multi-step equations that have variables and constants on both sides. And with a little bit more work and practice, you will be able to look at these problems and not feel intimidated at all.